According to the California Electrical Code, all electrical service panels must have a main disconnect switch or circuit breaker that meets the following requirements. Firstly, it must disconnect all electrical circuits in the service panel. Secondly, it must be easily accessible to occupants. Thirdly, it must be located outside the service panel enclosure. And fourthly, it must be clearly labeled as the main disconnect. In general, electrical systems installed before the adoption of modern codes are grandfathered in and allowed to remain in place, even if they do not fully comply with current codes. However, this does not apply to safety-related issues such as the presence of a main disconnect switch. Homes built in 1960 in California may or may not have been required to have a main disconnect switch, depending on the specific local building codes in effect at the time. However, modern codes clearly require a main disconnect, and it is strongly recommended to have one installed if it is not already present for safety reasons. Regardless of whether it is a code requirement or not, it is always a good idea to have a main disconnect switch installed in the electrical panel of a home built in 1960. This provides a convenient and safe way to disconnect all power to the home in case of an emergency, maintenance, or remodeling. An electrical panel, also known as a breaker box or load center, is a metal box that houses circuit breakers or fuses. These devices protect individual circuits from overloads and short circuits. The main disconnect is a switch or circuit breaker that allows you to shut off all power to the entire electrical panel. This can be useful in a variety of situations, such as during an electrical fire, when performing electrical work, or when leaving the home for an extended period of time. The California Electrical Code, or CEC, is a set of regulations that govern the installation and maintenance of electrical systems in the state of California. The CEC is based on the National Electrical Code, or NEC, but it includes some additional requirements specific to California. The CEC requires all electrical service panels to have a main disconnect that meets certain requirements. These requirements are intended to ensure that the main disconnect is easily accessible, clearly labeled, and capable of disconnecting all power to the electrical panel. The concept of grandfathering refers to the practice of allowing existing structures or systems to remain in place, even if they do not fully comply with current codes. This is often done to avoid the cost and disruption of having to upgrade existing structures to meet new codes. However, grandfathering typically does not apply to safety-related issues. This means that even if a home was built before the current electrical codes were in effect, it may still be required to have a main disconnect if it is deemed necessary for safety. Homes built in 1960 in California may or may not have been required to have a main disconnect switch, depending on the specific local building codes in effect at the time. However, modern codes clearly require a main disconnect, and it is strongly recommended to have one installed if it is not already present for safety reasons. There are several reasons why it is a good idea to have a main disconnect switch installed in the electrical panel of a home built in 1960. Firstly, it provides a convenient and safe way to disconnect all power to the home in case of an emergency. For example, if there is an electrical fire, you can quickly shut off the power to the entire home to prevent the fire from spreading. Secondly, it provides a convenient and safe way to disconnect all power to the home when performing electrical work. This can help to prevent electrical shock and other injuries. Thirdly, it provides a convenient and safe way to disconnect all power to the home when leaving for an extended period of time. This can help to prevent electrical fires and other hazards. The main disconnect should be easily accessible to occupants. This means that it should be located in a place where it can be easily reached in an emergency. The main disconnect should be located outside the service panel enclosure. This is to prevent accidental contact with live electrical parts. The main disconnect should be clearly labeled as the main disconnect. This will help to ensure that people know how to use it in an emergency. The California Electrical Code is updated every 3 years. The latest version of the CEC is the 2022 edition. The CEC is available for purchase from the California Building Standards Commission. It is also available online at various websites. If you are unsure whether your home meets the current electrical codes, it is best to consult with a qualified electrician. A qualified electrician can inspect your home's electrical system and make recommendations for any necessary upgrades. It is important to keep your home's electrical system in good working order to ensure the safety of your family. Regular maintenance and inspections can help to identify and correct potential problems before they become serious hazards. Electrical safety is an important concern for all homeowners. By following the recommendations in this guide, you can help to ensure the safety of your home and family. Always hire a qualified electrician for any electrical work. Do not attempt to do electrical work yourself unless you are properly trained and qualified. Be sure to turn off the power at the main disconnect before performing any electrical work. Use caution when working around electricity. Electricity can be dangerous, and it is important to take precautions to avoid electrical shock. If you are unsure about anything, consult with a qualified electrician. A main disconnect provides a single point of control for cutting off all electrical power to a building or a specific section of it. This is crucial for safety during emergencies like fires, floods, or electrical malfunctions. In such situations, quickly disconnecting power can prevent further damage and protect lives. During electrical repairs or maintenance, a main disconnect ensures that the entire electrical system is de-energized. This eliminates the risk of electrical shock and makes the work environment safe for electricians and other personnel. By isolating the electrical system, a main disconnect allows for safe troubleshooting and repairs without the danger of live wires. During renovations or remodeling projects, it is often necessary to shut off power to specific areas of the building. A main disconnect allows for the isolation of these areas, enabling safe work without affecting the entire building's electrical supply. This targeted power shutdown minimizes disruption and allows other parts of the building to continue functioning normally. Modern electrical codes often mandate the installation of a main disconnect to comply with safety standards. Adhering to these codes ensures that the electrical system meets the necessary safety requirements and reduces the risk of electrical hazards. Compliance with electrical codes not only ensures safety but also helps in maintaining the property's value and insurability. Regular inspections and adherence to code requirements can prevent potential legal and financial liabilities. A main disconnect provides a way to completely de-energize the electrical system, preventing energy leakage and reducing the risk of electrical fires when the building is unoccupied for extended period. This is particularly useful for vacation homes or buildings that are temporarily vacant. The ability to shut off all power also helps in conserving energy and reducing electricity bills during periods of non-occupancy. Installing a main disconnect can increase the overall safety and value of a property, making it more attractive to potential buyers. A well-maintained electrical system with safety features like a main disconnect can be a significant selling point. The presence of a main disconnect demonstrates that the property owner has taken proactive measures to ensure electrical safety, which can instill confidence in potential buyers. An electrical panel, also known as a distribution board, is a critical component of an electrical system. It receives power from the utility company and distributes it to various circuits within a building. Understanding the function and components of an electrical panel is essential for ensuring safe and efficient operation. The main purpose of an electrical panel is to distribute electrical power safely and efficiently throughout a building. It acts as a central hub for all electrical circuits, providing overcurrent protection and control for each circuit. The panel houses circuit breakers or fuses, which are designed to protect individual circuits from overloads and short circuits. When a circuit experiences an overcurrent, the corresponding breaker trips or the fuse blows, interrupting the flow of electricity and preventing damage to the wiring and connected devices. Circuit breakers are resettable devices that can be switched back on after tripping, while fuses are single-use devices that must be replaced after blowing. The choice between circuit breakers and fuses depends on various factors, including the application, cost, and local electrical codes. The main breaker, also known as the main disconnect, is the primary switch that controls the power supply to the entire electrical panel. It allows you to shut off all power to the panel in case of an emergency or for maintenance purposes. Branch circuits are individual circuits that distribute power from the electrical panel to various loads throughout the building. such as lighting, receptacles, and appliances. Each branch circuit is protected by a dedicated circuit breaker or fuse. The busbars are conductive bars inside the electrical panel that distribute power from the main breaker to the branch circuit breakers. They are typically made of copper or aluminum and are designed to handle high currents. The neutral busbar is a dedicated busbar for connecting the neutral wires of the branch circuits. It provides a common return path for the electrical current. The ground busbar is a dedicated busbar for connecting the grounding wires of the branch circuits. It provides a path for fault current to flow back to the source, helping to prevent electrical shock. The enclosure of the electrical panel is a metal box that houses all the components of the panel. It provides physical protection for the components and helps to prevent electrical shock. The cover of the electrical panel is a removable panel that provides access to the components inside the panel. It is typically secured with screws or latches. The labeling of the electrical panel is important for identifying the different circuits and their corresponding loads. Each circuit breaker or fuse should be clearly labeled with the description of the load it serves. The proper grounding of the electrical panel is essential for safety. The grounding system provides a path for fault current to flow back to the source, helping to prevent electrical shock. Electrical panels are available in various sizes and configurations to meet the needs of different applications. The size of the electrical panel is determined by the number of circuits it can accommodate. The configuration of the electrical panel is determined by the type of power it distributes, such as 120 volts or 240 volts. Electrical panels should be installed and maintained by qualified electricians. Improper installation or maintenance can lead to electrical hazards. Regular inspections of the electrical panel can help to identify potential problems before they become serious hazards. It is important to keep the electrical panel clean and free of debris. Dust and debris can accumulate inside the panel and cause overheating. It is also important to make sure that all the connections inside the panel are tight. Loose connections can cause arcing and overheating. If you notice any signs of damage or wear to the electrical panel, it is important to have it repaired or replaced by a qualified electrician. Signs of damage or wear include cracked or broken components, loose wires, and evidence of overheating. The California Electrical Code, or CEC, is a set of regulations that govern the installation and maintenance of electrical systems in the state of California. The CEC is based on the National Electrical Code, or NEC, but it includes some additional requirements specific to California. The CEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and electrical equipment. The purpose of the CEC is to ensure the safety of people and property from electrical hazards. The CEC is updated every 3 years. The latest version of the CEC is the 2022 edition. The CEC is available for purchase from the California Building Standards Commission. It is also available online at various websites. All electrical work in California must comply with the CEC. Failure to comply with the CEC can result in fines and other penalties. The CEC is enforced by local building departments. Local building departments are responsible for inspecting electrical installations and ensuring that they comply with the CEC. If you are planning to do any electrical work in California, it is important to consult with a qualified electrician and to familiarize yourself with the requirements of the CEC. The National Electrical Code, or NEC, is a set of regulations that govern the installation and maintenance of electrical systems in the United States. The NEC is developed by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years. The latest version of the NEC is the 2023 edition. The NEC is widely adopted by states and local jurisdictions throughout the United States. The purpose of the NEC is to ensure the safety of people and property from electrical hazards. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and electrical equipment. The NEC is a complex and comprehensive document. It is important to consult with a qualified electrician and to familiarize yourself with the requirements of the NEC before doing any electrical work. Grandfathering in electrical systems refers to the allowance of existing electrical installations to remain in use even if they do not fully comply with current electrical codes. This concept recognizes that upgrading older systems to meet the latest standards can be impractical or excessively costly. However, grandfathering typically does not apply to situations where safety is compromised, and modifications or upgrades may be required to ensure a safe electrical environment. The primary purpose of grandfathering is to provide a practical approach to managing existing electrical systems while balancing safety considerations. It avoids the need for costly and disruptive upgrades simply to meet new code requirements, particularly when the existing system is functioning adequately and does not pose a significant safety risk. Electrical codes are regularly updated to incorporate new technologies, safety practices, and address emerging hazards. These updates can render older installations non-compliant with current standards. Grandfathering allows these systems to remain in service without requiring immediate upgrades, provided they meet certain conditions. The application of grandfathering is not absolute and depends on several factors, including the specific code requirements, the extent of the non-compliance, and the potential safety risks involved. Local authorities and electrical inspectors have the discretion to determine whether grandfathering is appropriate in a given situation. While grandfathering may allow certain aspects of an electrical system to remain unchanged, it does not exempt the system from ongoing maintenance and repairs. Regular inspections and maintenance are essential to ensure that the system continues to operate safely and reliably. If an existing electrical system is altered or expanded, the grandfathering status may be affected. Any modifications or additions must comply with current electrical codes, and this may trigger the need to upgrade the entire system to meet the latest standards. Grandfathering typically does not apply to situations where the electrical system poses a significant safety risk. If an inspector determines that an existing system is unsafe due to faulty wiring, inadequate grounding, or other hazards, they may require immediate repairs or upgrades, regardless of the grandfathering status. Some specific aspects of electrical systems are less likely to be grandfathered due to their direct impact on safety. This includes requirements for grounding, overcurrent protection, and emergency disconnects. These safety-related features are often subject to mandatory upgrades to ensure compliance with current codes. The interpretation and application of grandfathering can vary depending on the local jurisdiction and the specific electrical codes in effect. It is essential to consult with local authorities and qualified electrical inspectors to understand the specific requirements in your area. Documentation and record keeping are crucial for demonstrating the grandfathered status of an electrical system. Maintaining records of the original installation, any subsequent modifications, and inspection reports can help to establish that the system meets the criteria for grandfathering. When buying or selling a property with an older electrical system, it is important to understand the grandfathering status of the system. A thorough inspection by a qualified electrician can help to identify any potential issues and ensure that the system meets the necessary safety requirements. While grandfathering provides some flexibility in managing existing electrical systems, it is essential to prioritize safety and ensure that the system operates reliably. Regular inspections, maintenance, and timely upgrades are crucial for maintaining a safe electrical environment. Consulting with qualified electricians and local authorities is essential for understanding the specific requirements and ensuring compliance with applicable codes. The recommendation to install a main disconnect switch in the electrical panel of a home built in 1960 underscores the importance of electrical safety and convenience. While older homes may not have been originally equipped with this feature, adding a main disconnect offers several significant benefits. A main disconnect provides a quick and easy way to energize the entire electrical system in case of emergencies. This can be crucial during events like electrical fires, floods, or other hazardous situations. By cutting off power to the entire home, a main disconnect can help to prevent further damage and protect occupants from electrical shock. During electrical repairs or maintenance, a main disconnect ensures that the entire electrical system is de-energized, creating a safe working environment for electricians and homeowners. This prevents accidental electrical shock and allows for safe troubleshooting and repairs. A main disconnect offers a convenient way to shut off power to the entire home when leaving for extended periods such as vacations or seasonal absences. This can help to prevent energy waste and reduce the risk of electrical fires or other hazards while the home is unoccupied. Installing a main disconnect can be a valuable upgrade that enhances the safety and functionality of an older home's electrical system. It provides peace of mind and ensures that the home is equipped to handle modern electrical demands while minimizing potential risks. Adding a main disconnect can also increase the value and marketability of the home, making it more attractive to potential buyers who prioritize safety and convenience. The installation of a main disconnect should always be performed by a qualified electrician to ensure proper wiring, grounding, and compliance with local electrical codes. This helps to guarantee the safety and reliability of the installation. The electrician can also assess the existing electrical system and recommend any other necessary upgrades or repairs to bring the system up to current safety standards. A main disconnect typically consists of a large circuit breaker or switch located within the electrical panel. It is designed to handle the full electrical load of the home. The disconnect should be clearly labeled and easily accessible, allowing anyone to quickly shut off power in an emergency. The cost of installing a main disconnect can vary depending on the complexity of the installation and the specific components used. However, the investment is typically well worth it in terms of increased safety and convenience. While older homes may have been grandfathered under previous electrical codes, it is generally recommended to upgrade the electrical system to meet current safety standards, including the installation of a main disconnect. This can help to minimize potential risks and ensure that the home's electrical system is up to par with modern safety requirements. The installation of a main disconnect is a proactive step that demonstrates a commitment to electrical safety and provides a valuable safeguard for the home and its occupants. It is a relatively simple and cost-effective upgrade that can offer significant benefits in terms of safety, convenience, and peace of mind. Consider having a qualified electrician assess your home's electrical system and recommend the installation of a main disconnect switch. This can help to ensure that your home is equipped with a modern and safe electrical system that meets your needs.